I want to reference whenever we're talking about, that problem that was the most missed problem on the test is this one that asked you what's the confidence level. So the problem that on the free response asks you to interpret the confidence level of the interval in context. And pretty much people that did that problem for the most part interpreted the interval, not confidence level. Most people said, I'm 95% confident that the true proportion of all households that own at least one dog is between this number and that number. So you interpreted the confidence interval. And interpreting the confidence level is different than that. Okay, there's even like a separate song about it, and it was on the back of your Chapter 19 quiz, and I did go look up the grading guidelines by the College Board. I actually have them whenever I grade those free responses, because that is an actual free response question. And so I went and I re-looked at the way that they graded it on the AP exam, because I thought maybe they gave half credit if you did the interval instead of the level, and I would then give you half credit. But they didn't. If you did not interpret it correctly, and you interpreted it as a confidence interval, it was considered incomplete, and it was 0 points. Okay? So that's what I did. Alright, so this problem that we're going to first start with is about the average speed of all vehicles on this particular road. Okay? So what is the purpose of an interval? What does an interval do for you? An interval is a range of numbers, and what are those numbers supposed to do? You're containing or estimating the population parameter. So an interval is estimating the population parameter. And when I say population parameter, I'm talking about the population proportion or the population mean. So you are hoping that you take a sample, you make an interval out of it, and you're referencing how confident you are that you contain the true proportion or true average. Okay. So what happens is we need to understand a couple of things. And so I have a picture of our intervals that we've got. Let's take a look at this. Okay, so there is our intervals that we made with the true proportion of water on the globe. We made all of those intervals. And I'm going to say that, of course, technically we never really know, that this red line down the center right here, which I just am coloring blue, is that population P. So this is that population value of the true proportion of water on the globe. Okay? So all of these intervals were created, every single one of these intervals were created from a what? A sample. Good. So all of these intervals were created from a sample. Okay, so intervals were created by a sample. And here's the thing. We cannot, with an interval, you cannot make a statement about, it is not about individual items in the interval. It's not about individual globe tosses. It's not about individual items in your interval that you created. Okay? An interval is also not about other samples being in your interval. Okay? So it's not about a car being in that interval you created, or someone else's sample average being in your interval. It has to do with, it is about a population P or a population mu being in that interval. Okay? And then one other thing, and then we're going to get to the actual interpretation of these intervals that we're going to be doing today. Here's the other item that I want to talk about. Let's say that this is the true population value. Okay? Well, that amount, that red line, doesn't move. You cannot say that this true line is in your interval 95% of the time, and 5% of the time it's not in your interval. The population answer is set. It is not sometimes in your interval and sometimes not in your interval. The intervals move around, but this red line is a set, stagnant amount, and it doesn't change. It's an amount that doesn't move. So there's not a probability about it being in or out. Okay, so with that discussion going down, let's now talk about what these problems up here say. So here we go. All right, so this problem is about the average of all vehicles that go on this particular road. Okay, so let's go ahead and write down the parameter. This problem, put mu equals the average speed, I didn't say that earlier, the average speed of all cars on this particular road, Trip Hammer Road. Okay, so apparently the sample that this person got was 31 and then made an interval. So this person got a sample mean of 31 and made an interval that went from up to 32.5. And I don't know the confidence. It looks like it's 90% confidence interval. Okay. Okay, so here are statements that you cannot say about this. I mean, we could say 90% of all 90%. We can say these two down here. 90% of all 90% confidence intervals contain the true average speed of all the vehicles on Trip Hammer Road. And we can say, I'm 90% confident that the average speed of all cars on Trip Hammer Road is between 29.5 and 32.5 miles per hour. But here's ones you cannot say. Here's what this first one says. 90% of all the vehicles on Trip Hammer Road drive at speeds between 29.5 and 32.5. Okay, so think about what that's saying. Here's your speed bounds, 29.5 to 32.5. It's saying 90% of all the cars have speeds in between there, and 10% of cars have speeds outside of that. Is that what the interpretation of an interval is telling you? No. An interval is not about these individual cars being different speeds outside. An interval is about average. Is the true average inside that interval, not about individual cars, individual values being in that interval. You could have a little old granny being down here at 15 and a teenager being up here at 45, and those will average out to be a number inside there. Okay, next. We are 90% confident that a vehicle will have a speed 29.5 to 32.5 miles per hour. What do you think about that? Okay, good. Again, it's not about, it's an interval about average, not about an individual value. Okay, good. So that's what's bad about those two statements. All right, here's a couple other things. Here, this is nice. The average speed of the vehicles, so that sounds good so far, is 31 miles per hour 90% of the time. What do you think about that one? Okay? We don't have an interval interpretation, but here, to me, is the real problem. If you're saying the true average is 31, 90% of the time, what is it the rest of the time? Something else, right? You're saying 10% of the time, mu is something else. Mu doesn't change. Remember I told you on this picture right here, whenever we have that line, mu is not right here sometimes and then sometimes over here. The population value doesn't change. It stays there. And so that is what is wrong with this statement here. It says that 90% of the time it's this, which implies 10% of the time it's something else. That's bad. Okay, here's the next one. 90% of all samples will have means between 29.5 and 32.5. So what's the deal with that? 90% of all samples will have means between 29.5 and 32.5. No, it has context. It has average speeds. It has context of the miles per hour. It has the bounds of the interval, 29.5 to 32.5. Is an interval about other samples being in your interval? No, that's the problem with that statement. Your interval is not about other samples being in your interval. So it's not about your x bar or your x bar or your x bar or your p hat or your p hat or your p hat or whatever your other samples are in my interval. It's not that. So it's not about individuals being in your interval. It's not about samples in your interval. It's about the p or the u being in your interval. Pu, okay, or the mu. All right. So let's go back and let's try a couple of these on our own. So again, that's what was wrong with this one right here. The interval we calculate does not, the interval that we calculate, I like this the way it says it. It does not set a standard for every other interval. So your interval that you make is not set a standard for other intervals being in it. Okay, so what I want to do next, turn over to page 12. And I've got a series of these here, and they're going to kind of take, I mean, for real, when I learned how to do these things, they're tough. I mean, they mess with my head. So I had to, I learned how to do these by just looking at the problem and kind of studying what the answer was, and then I just kind of learned from there. So I'm going to do that. I'm going to do several of these with you, so you can kind of learn, and then I'm going to set you and let you do some on your own, and then we'll check and see how you do. Okay, so this first one says, a catalog sales company promises to deliver orders placed on the internet within 3 days. Follow-up calls to a few randomly selected customers show that a 95% confidence interval for the proportion of all orders that arrive on time, so we're doing a proportion problem, is 88% plus or minus 6%. Now that actually brings me to a thought that I had about another thing that y'all totally sucked it up on the test. Was this. And yes, that's on the recording, but there you go. Okay, so explain to me what this means when it's talking about the interval. Maybe I should go with it on what's on that. This is your p hat, plus or minus your margin of error. This does not mean that your interval is going from 0.119 to 0.4, I think that was a 7, 0.417, or whatever it was. That is not what that means. That means you take 0.419 and you add 0.119 to get this upper bound. You take 0.417, and you subtract it to get the lower bound, and your interval is gone from those bounds, which is what they did right here on this. If they say 88% plus or minus 0.06, then they made an interval that went from what to what? 82% to 94%. That's what that means. It's your p hat plus or minus your margin of error. All right. Okay, moving on. Sorry, sidetracked. So, with this situation, does this mean that between 82% and 94% of all of the orders arrive on time? Is that how you interpret that interval? Okay, what's wrong with it? Ah, very good. It's about all of the individual orders. This is similar to that statement about all the cars. 90% of all the vehicles on Trip Hammer Road go between that speed and that speed. So this is similar to why this problem was wrong. Okay, so back over to here. Yes, it's about the average, the true average of all of the cars. So here's what I wrote. No, I'm 90, actually not average. This is a percent of orders. Sorry. I am 95% confident that the percent of all of those cars that arrive on time is between 82% and 94%, and the 95% confident is also not in there. 95% confident that the true proportion that arrive on time is between 82%. The percent of all cars. Okay? So there's a couple things that was wrong with that one. All right. Let's take a look at another one. Here comes the next. Okay, here we go. Same situation with the things arriving on time. Okay, so the statement says, does this mean that 95% of all random samples of customers will show that 82 to 94% of orders arrived on time? Okay, so what's wrong with that? Right. This issue, what is this saying? That everybody else's what? P hats are going to be in my interval. Is an interval about other people's samples being in my interval? No. An interval is not about other people's samples being in my interval. So that's the problem there. Okay? Alright, so back to that. I wrote this. This statement, and I wouldn't write both of these down. I just do that top part. The top part says, this statement is about other samples being in the interval that I created. And that's what's bad. This statement is about other samples being in the interval that I created. And that's what's bad about that. Okay. Now I want to do one more with you, and then okay, so here's this last one. It's the same situation. Does this mean that we are 95% sure? It says sure, but we'll say that's like saying confident. 95% confident that between 82% and 94% of the orders placed by the customers in this sample, meaning like my sample, I made this interval 82 to 94. Does that mean I'm 95% confident that between 82 and 94% of the customers in my sample arrived on time. Okay, so what do you have to say about that? How do I make an interval? Well, we already said I got a p hat of 0.88, and what did I do with it? I did my margin of error. So am I 95% confident that between 82 and 94%, this is my sample results? What do you have to say about that? And the interval. What do you have to say about 0.88 being in the interval? Am I 95% confident it's in there? I'm 100%. Gosh darn it, I made the dadgum interval off of my p hat, so of course it is in there. Okay? So here's what I have to say about that. This is about the confidence of having the sample that we got being in the interval. And so I actually did something very not very too professional. I said, duh, our sample lands. So let's change that. Of course. Let's sound a little bit more professional. Of course our sample lands in the interval. We made the interval off of our sample. I think that's the most compelling argument right there. Of course our sample lands in the interval. We made the interval from that sample. So I think the key to these problems is understanding what's it talking about. Like, is it talking about individual items? Is it talking about samples of items? Is it talking about the whole population of items? Okay, so I want to give you a few minutes and have you do the 3 on the next page, because you don't get this stuff until you think about it in your head yourself. Guaranteed. You don't get this stuff until you put some brain power into it yourself. So I want you to do those next 3 and then we'll check them. So let you have a few minutes to do that. These are tough, aren't they? So I see you have lots of uncertainty about it, so let's go over those. Okay, this first one says, does this mean that on 95% of the days, between 82% and 94% of the orders will arrive on time? Okay, so this is a no, and the issue is the 95% of the days. And it's not even technically that it's because it's about days instead of the orders or whatever. So, any thoughts on that? 95%. Think of this as saying 95% of the time. If you think of saying 95% of the time between 82% and 94% of the orders will arrive on time, what's going to happen the other 5% of the time? It's going to be what? Late or something else. So wait. So 95% of the time, the true proportion will be located right here where this red line is. The other 5% of the time, okay, can do that. The other 5% of the time, the true proportion is going to be somewhere else. 95% of the time, the true proportion is going to be there. The other 5% of the time, the true proportion is going to be somewhere else. Can that happen? Does this true value move around? No. It's not there sometimes and sometimes somewhere else. That's what the problem is with this statement. So therefore, here's how I wrote that. 95% of the days implies that there is a probability of the true probability landing in there. I mean, sometimes it does, and then I would just kind of leave it at that. You are saying sometimes true P is in the interval, and sometimes P true P is not. And that's what's wrong. You cannot say sometimes true P is in there and sometimes true P is not. True P does not move around. You cannot say sometimes true P is in the interval and sometimes true P is not in the interval. True P is stable and doesn't move around. Okay. Now, let's go on to this second one. About this one. Oh, this was another situation. This one was a situation, this was interesting. This actually was worldwide headlines where they did one sample and they got 56% heads. 56% heads. And so then they got a 90% confidence interval from 51% to 61%. So, does that mean that's an unfair coin and it lands on heads more frequently than 50% of the time? Okay, so that's what we're wondering. So this says, does this mean that if you spin a euro many times, aka, what does this mean? If you spin a euro many times, what are you doing? You are getting a what? Another sample. Yeah, and I think these are proportions of times that you are getting a sample p hat. So if you do some other p hats and all y'all did your own p hats, you can be 90% confident of getting between 51% and 61%, whatever it said, heads of the euro. Okay, so what's wrong with that? This problem is saying it's about another sample. Oops. Hold on. It's about another sample being in the interval that we created. That's the problem with that. It's about another sample being in the interval we created, and that's a problem. Okay? So that means this last one is okay. 90% confident that the proportion of spun euros will land on heads between 51 and 61% of the time. So the true proportion, I'm 90% confident that the true proportion of all spun euros will land between 51 and 61% of the time. Okay, those are tough. I am going to have you not do pages 14 and 15 for now. We may do those another day. But your homework assignment is to do pages 16 and 17. Okay? So let's discuss those real quick. Page 16 is this problem here about the livestock, and you take a sample of 77 and you got a sample average of 56 pounds. Okay, so you got a sample average, so there's your X bar of 56 pounds. Okay, so your X bar. And so then they ask you things about interpretation of the interval and so on. Okay, all of these statements are wrong. I will tell you. I'll leave these two up here so you can write those down correctly, but statements A through F all have something wrong and you're supposed to say, what's wrong with it. Okay, and then the next page is warm up for chapter 23, and that's because you have your quiz tomorrow. It's a sample of 24. Oh no, what does that mean? It's not large enough. So in order to meet the conditions, and you do have the individual items given to you, so guess what you're probably going to have to do. But I wanted to tell you that on this confidence interval, see, you're going to do a test first, and then the interval, you will be allowed to say that the parameter and assumptions are the same as above, and you won't have to do the parameter and assumptions again. You'll just have to then do the interval, and the interval you can do by putting it into your calculator because it's all done with this data here, like that. Okay, there you go. So your homework is pages 16 and 17, and we have a quiz tomorrow.